This is Unit 2, Day 5, Example 32. In which of the following x and y are directly related? Solve for the missing value. Alright, so basically you have to memorize that direct variation, or anything that varies or is directly related, you're going to set up a proportion and you're going to cross multiply. Okay? It's very easy, very basic. Okay, just pay attention to the order of the labels. So, ready? Look. So you say, it's kind of like you're going to put y over x, right? So keep that as a order. So 15 is to 5. So when y is 15, x is 5. And then it says, well, if y, what is y going to be when x is 9? So again, y over x is y over x. You cross multiply, and you're going to get that y is 27. Okay, you could also reduce that and realize that that has a scale factor of like 3. So if 15 divided by 3 is 5, so then you could say what divided by 3 is 9. So you could use mental math there, but not all of them work out nice, like if you'll see this next one. So ready? Negative 6 over 4. So y over x is y over x. Not so easy with mental math. Cross multiply, and you'll get y equals negative 13.5. Part C. Y over x is y over x. Okay, cross multiplication, y is 18. Alright, so direct variation. We say that two variables are directly related or directly proportional to one another if the following relationship holds. Again, so it's any y over x is equal to k, and k is always the constant. Okay, that's the constant of variation. So by taking your y value and dividing it by your x, that is the constant of variation. Sometimes the questions will have you find that. All right, these next couple examples, set up a proportion and cross multiply. So the major word here is varies directly. So the distance a person can travel varies directly with the time that they've been traveling if going at a constant speed. So it's distance compared to time. So keep that in order of your proportion. So traveled, so it says if Phoenix traveled 78 miles. So it's distance in 1.5 hours. How far, so what is the distance in 2 hours? So it's miles over hours is miles over hours. Cross multiply, and you're going to get that x is 104. So he traveled 104 miles in 2 hours. Should make sense. It's more than an hour and a half. Because an hour and a half, he only went 78 miles, so it's definitely going to be bigger than 78. 34. Jenna works a job where her pays vary directly with a number of hours. So it's pay versus number of hours. Okay, that's the label comparison. In 1 week, she worked 35 hours. So hours is on the bottom. And she made, the pay, is $274. Oops. And 75 cents. How many hours, so that's the bottom one, would she need to work in order to earn $337.55? So again, you're just going to cross multiply, and you're going to get 43 hours. So she has to work 43 hours to make $337.55. Example 35. So more on direct variation. Two variables, x and y, vary directly. So that's like x over y. When x is 6 and y is 4, so remember, it's going to go x over y. So that's basically like 6 over 4. You could use 6/4, or its equivalent fraction is also going to be what? You divide those both by 2 and you get 3/2, I believe. Actually, you know what? Let me put y over x. So y over x. So it would be like 4 over 6, and 4 over 6 reduces to 2/3. You'll see why I'm putting y over x in a minute. Alright, the point is shown plotted below. Find the y values for each of the following x values. Again, you can make the choice of using 4 over 6 or 2/3. It does not matter because they're equivalent. But just stay in order if you're going to do y over x or x over y. So I'm going to use the y over x. So ready? 4 is to 6, and it's y over x. is y would be to 3. Again, it's y over x to keep that in mind. You're going to cross multiply, and you get y is 2. Okay, another way is mental math here. 4 divided by what? Okay, 6 divided by 2 is 3, so 4 divided by 2 is going to be 2. Again, y over x, so 4 is to 6, as y is to negative 6 is the x value. You're going to cross multiply, and you're going to get y equals negative 4. Okay, what is the constant of variation? Constant of variation is y divided by x equals that k. And k is the constant of variation. So the y value was 4 divided by the 6 reduces to 2/3. So 2/3 is the constant of variation. What does it represent on a line? Plot each point. I'm sorry, I didn't go up to part A. So you have to plot the points here. So you have x is 6, y is 4. So you plot 6, 4, boom, that's already on the graph. I could plot the point 3, 2. That's right from here. When x is 3, y was 2, it's a coordinate. And then when x was negative 6, then it went down to negative 4. Okay, so here's that graph. Okay, guess what 2/3 is? Part B here. What does that represent? The constant of variation is its slope. So look, if you went up 2 over 3, that is your slope. So the constant of variation represents the slope. Write the equation of the line that you plotted in A. Now remember, the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So for this one, my slope is 2/3. And look, the y-intercept, it's at the origin, so it's 0. So this is my equation of my line. Example 36. The miles driven by a car D varies directly with the number of gallons G of gasoline used. Abigail is able to drive D equals 36 miles on a gallon 4. Okay. Calculate the constant of variation for the relationship D over G. Well, 336 is my D, 8 is my G. I divide that, and I'm going to get 42, and it says, please make sure you include a proper units in your answer. So it's 42 over 1. Now, the reason you have to do it over 1, you can't just leave it 42, because remember, it's representing miles per gallon. So you can't say 42 miles, it's per 1 gallon. Okay, so you could also do something like this. That means the same thing, 42 miles per gallon. Give a linear equation that represents this relationship between D and G. Express your answer as an equation solved for D. So you got to isolate D. All right, so ready? D over G equals 42. Because remember, that's my constant of variation. So if I cross multiply this, I get D equals 42G. Okay? So the distance driven would be 42 times the number of gallons. So how far can Abigail drive on G equals 6 gallons of gas? So use D equals 42G. Now it wants G is 6, so D is equal to 42 times 6. You can get that. You're going to get D is 252 miles. So on 6 gallons of gas, you could go 252 miles. Okay, how many gallons of gas, so you're solving for G, will Abigail need in order to drive 483 miles? So that's your D. D is 483. So you're going to go 483 equals 42G. Divide both sides by 42, and you'll get G equals approximately 11.5 gallons. Okay, so you're going to need 11.5 gallons of gas. All right. Average rate of change. Okay, in algebra, you learn that that is slope. Okay, average rate of change is your slope. Okay, this is really fancy when you guys start reading this, but don't forget, it's the change in y over the change in x, which used to be this little formula like this. So it's y minus y over x minus x. Remember, that's your little lowercase m there. Okay, so for example 37, the function f of x is shown on the graph to the right. Evaluate each of the following. Okay, so f at 0. F at 0, come to the graph, you're at 1. So this is just 1. Okay, f at 4, go over to 1, 2, 3, 4. You go all the way up and that has a value of 7. F at 7, so go over 7, you come all the way up. Okay, so over 7 up, that has a value of 10. And our last one here, part 4, F at 13. So come all the way over to 13, you go all the way up, you're at a value of 15. So these are almost coordinates, okay? They are coordinates. So that's the 0.01, that's the 0.47, and vice versa. Find the change in the function, so change in f, over the following intervals. So now remember, change in f is really change in y. So you want to see what it's changing. So from 0, which is here, here's 0, to 4, what is it changing on the y? So you're just finding how many up. Okay, don't go how many over because it only wants the change in y. So you want to figure out how many up did I just go. So normally we go how many up, how many over, but it only wants the change in y right here. So from 0 to 4, I just went up 6. So because I went up 6, my answer is 6. Okay, so just count the y's. So now the other one is saying from 4 to 7. So how many did I go up before I had to go over? And it only wants that number. I went up 3, so my answer is 3. Okay? Again, a delta F means only the change in y. And then from 7 to 13, here's how many I went up. And I went up 5. So my answer is 5. Okay, pretty easy there. Just kind of breaking down and seeing what they want you to answer. Why can't you simply compare the changes in f from part B to determine over what interval the function's changing the fastest? I'm going to actually come back to that one in a minute. Okay, I'll come back to that one in a minute. But part D, calculate the average rate of change for the function over each of the intervals and determine which interval has the greatest rate. Okay, so this is basically you're calculating the full-blown slope. So from 0 to 4, okay, here's 0 to 4, you went up 6 over 4. Up 6 over 4. So this is 6/4. You put 6/4 in your calculator and it's approximately 1.5. Okay? For the next interval, it's going to be the last one I'm going to draw in. From 4 to 7, you went up 3 over 3. So because it's up 3 over 3, that reduces to 1. Okay? And from 7 to 13, you went up 5 over 6. That is approximately, sorry, I don't like the way that looked. Up 5 over 6, that is approximately 0.83 repeated. So now it says, calculate the average rate of the change. Which one has the greatest rate? Choice 1. Okay, 1.5 is that biggest number. Okay, now going back to part C, why can't you simply compare the changes if f from part B to determine over which interval is changing the fastest? Well, you can't because the change in x changes. So every time your delta x, meaning the change in x, that changes. So you can't just judge it by 1. Okay, so this graph didn't have the constant rate of change, which would make sense because it's not linear, and only linear would have that. Okay? All right, question 38. Consider these two functions. They give you the f function and the g function. Calculate the average rate of change for both functions over the following intervals. Show the calculations. Now remember, guys, these are the x values, so they want you to substitute it into x. Okay, so really, you're going to do f of -2, and you're going to do f of 3. But it wants it in both functions. Okay, so make sure you do that. So f at -2, just simply take this -2, go up here. It becomes 5 times -2 plus 7, and you're going to get -3. Okay, f at 3, plug in a 3. 5 times 3 is 15 plus 7, you get 22. Okay, and you can do that same thing. Okay, so now, ready? Watch this. Remember, this is like the coordinate -2, -3. It has an x and a y value. So now you just kind of calculate slope. Okay, so ready? It's going to be, I'm running out of time here, so I'm going to pick up in 1 second, okay?